Now we have this question on the board, and I kind of like this question. Do you know why I like it? Don't worry, you're going to find out later when we start interpreting the domain of this problem. Are you ready? Remember that for a function of this kind, all you need to do is to set the term inside the square root sign to be greater than or equal to what? 0. Now if you look at this 16 can still be written as 4 squared minus x squared. Therefore this is difference of 2 squared. And you know that when you have difference of 2 squared, what does that mean? Or how do you get the result? It simply means 4 minus x, then 4 plus x will be greater than or equal to 0. Quickly recall this in mathematics. Difference of 2 squared. If you have a squared minus b squared, it's going to give you a minus b, and then a plus b, okay? If you expand this, you still get this. So from here, we are going to pick each of them and then make it greater than or equal to 0, then solve for x. Let's do that. Pick this, 4 minus x is greater than or equal to 0. Now, if this because this is minus x, I want to take it this way, alright? Or perhaps take this 4 to the other way. If it moves, you're going to have minus x to be greater than or equal to. If this 4 crosses, it will become minus 4. And then what do? You can divide through by minus. Alright? If you divide through by minus, when you are dividing inequality sign through by minus, or you're multiplying through by minus, the sign will change. Is that okay? So this will be the same as x. You change the sign to less than or equal to 4. We are done with that. Or the second case, you have 4 plus x to be greater than or equal to 0. If you solve for x here, you're going to get this 4 will cross to give you minus 4. So you see that what you have here is x less than or equal to 4, positive 4, and then x greater than or equal to what? Minus 4. Let us interpret this now so that when I'm putting the domain, you would understand why I had to do that. Now I'm going to draw a number line on this, then locate my 0 in the middle. Is that okay? As usual. Now let me take here to be minus 4 and here to be what? Plus 4. Okay, so you notice that this way goes to negative infinity. This way goes to what? Positive infinity. Is that okay? Infinity. Now, for this function, because this number came before this variable x squared, what it simply means is that the domain of this function is between minus 4 and plus 4. In fact, if you are to draw this inequality, for this that is x less than or equal to 4, it will be from here. You go this way. Is that not so? If you worked a number line before, inequality. And then for x greater than or equal to minus 4, it will go this way. So you see that these two will link. Is that not so? All it simply means is that the domain of this function exists for any number between minus 4 and 4. In fact, alright, and it means that f of x between numbers from minus 4 to plus 4 is element of real numbers. By implication, it goes to mean that any number below minus 4 and above plus 4 will not give you a real number for f of x here. It will not. Therefore, I'll write my domain to be equal to, for this case, it just says minus 4 comma plus 4. That's your result. That's how you quote the domain. Stating that the real numbers that you will obtain will be produced by numbers between minus 4 and plus 4. And that is why I told you I like this problem, okay? Because, see, if this were to be x squared minus 16, then the domain would no longer be numbers between this minus 4 and plus 4. It will be numbers outside it, to positive infinity and to negative infinity. The next video we're going to solve a problem of that kind, okay? But for this, where this number appeared before this variable x squared, then for you to get the domain is all numbers between the two limits that you got. And so we have this question on the board. Find the domain of the function square root of x squared minus 4. How do we solve this problem? Once again, x squared minus 4, set it greater than or equal to 0. You would recall in the previous question number 8, we had square root of 16 minus x squared. I told you that for that, the domain will be numbers between the limits of x you obtained there, because 16 as a number came before the square of x. And I told you to watch out, we're going to solve another problem where the square of x comes before what? A number. In that previous example or question of number 8, We say that the domain are all numbers between those limits of x you obtained. But that if square of x came before the number, before your number here, then the domain will be numbers outside the limit of x you are going to get here. Now let us solve this problem together and see what I really mean by that. Solving this, this will be x minus 2, then x plus 2, difference of 2 squared. This is 2 squared, you know that, right? And then greater than or equal to 0. I am a little bit unfortunate here. It has dawned on me. There is something I didn't show you in question number 8. I can't avoid it here anymore. The actual process of solving this problem. If you just come and say this greater than or equal to 0 and then you solve for x, then x plus 2 greater than or equal to 0 is solve for x, that is really wrong. If you have a problem like this is the actual way of solving it and the real mathematics. For the multiplication of two things to be greater than or equal to 0, it means that those two things, both of them are greater than 0. Or those two things, both of them are less than 0. That is what it means. Therefore, I will create two cases here. Case 1, where x minus 2 is greater than 0 and x plus 2 is greater than what? 0. That is, both of them are greater than 0. Doing that, if I solve from this x minus 2 greater than or equal to 0, we're going to have that x is greater than or equal to 2. Or, in the second part, x plus 2 greater than or equal to 0, we're going to have that x is greater than or equal to minus 2. Now, I am going to ask you a question here so I will know the limit to pick. If something is greater than or equal to positive 2 already, do you need anybody to tell that that thing is already greater than or equal to minus 2? Do you need to be told? No. For something to be greater than positive 2 means the thing is already above minus 2. So here, the limit we're going to pick is x greater than or equal to 2. Now we go to case 2. In case 2, we have that both of them should be less than or equal to 0. The x plus 2 less than or equal to 0. From this first aspect, x minus 2 is less than or equal to 0. If you solve it, you have x is less than positive 2. Then coming here, x plus 2 less than or equal to 0. If you solve it, you have x is less than or equal to minus 2. Now and again, I'm going to ask you another question. If something is already less than or equal to negative 2, do you need to be told that that thing is already less than positive 2? Not at all. For something to be less than negative 2, that thing is already less than positive 2. So from here, this is the correct limit to pick. X less than or equal to minus 2. Now you see this, right? Let us draw the number line of that. 0, let me take it as positive 2, and here as negative 2. You know that this goes to what? Positive infinity. This goes to negative infinity. Now, if I draw the number line inequality for this x to be greater than or equal to positive 2, it will start from here and go this way. Is that not so? And then if you draw for the other part, x is less than or equal to negative 2, it will go this way. You see that this is apart. Is that not so? The interpretation means that to get a real number for this, f of x is not element of real number in between here. That is to say, numbers between minus 2 to plus 2 can never give you a real number for this function. Therefore, the domain of these functions are numbers from positive 2 to positive infinity and from negative 2 to negative infinity. You can see the way the arrows fit. And so, we're going to write that domain is equal to, this is how we present the domain of this. You have an open bracket starting from minus infinity and end at minus 2. It closes there, jumps some numbers, some real numbers, and then union, start again, that is open from positive 2 and then end at positive infinity. That's how you quote the domain.